Welcome to the second video of the ECG Express, the conducting system of the heart. In this video, let's take a quick recap of the conducting system of the heart. This is the basic framework of the electrical wiring of the heart. Let me make it more clear for you. Let's start with the SA node. The SA node is also known as the pacemaker of the heart. The SA node depolarizes the right atria through three intra-atrial pathways. And those are 3 in number, and this helps in the depolarization of the right atria. So what about the left atria? The question arises there. The left atria has something called as the Batchman's bundle, through which the SA node depolarizes it. So the left atria, Batchman's bundle; right atria, intra-atrial pathways. Once more, the left atria, Batchman's bundle; the right atria, intra-atrial pathways. So now the impulse reached the atrioventricular junction. The atrioventricular junction. Here, there is the presence of something called as the AV node. Fortunately, the impulse slows down here. Fortunately, I'm saying fortunately, because this AV nodal delay helps in the complete emptying of the blood from atria to the ventricles. So after depolarizing the right and the left atria, the impulse reached AV node, and now from the AV node, it enters a specialized conducting tissue. This is our bundle of His. This is known as the bundle of His. And you know what? The bundle of His further divides. This divides into the left bundle branch and the right bundle branch. Left again divides into 2. Let me make it more thicker. Why? Because this is the left posterior fascicle, which is thicker, and this is the left anterior fascicle, which is a narrow band. The left posterior fascicle, what does it do? It's a thick band of fibers which helps in the depolarization of the posterior and the inferior parts of the left ventricle. So what does the anterior fascicle do? It helps in the depolarization of the anterior and the superior parts of the left ventricle. Now, after being traversed a long distance from the SA node, the impulse finally reaches its final ramification, which is known as the Purkinje fibers. But what do these Purkinje fibers really do? Imagine this is the heart, and this is the endocardium, and this is the epicardium. The Purkinje fibers transmit the signals from endocardium to epicardium in this way. This is how the whole impulse travels from the initial SA node to the final point of the epicardium. Let's revise it again. The impulse starts from the SA node. The right atria depolarizes through specialized intra-atrial pathways, and those are 3 in number. And the left atria depolarizes through something called as the Batchman's bundle. After depolarizing the right atria and the left atria, respectively, the impulse reaches the atrioventricular junction, where there is AV node. I told fortunately there is something called as the AV nodal delay, which helps in the emptying of the blood from the atria to the corresponding ventricles. Now, after the AV node, the impulse enters a specialized conducting tissue called as the bundle of His. The bundle of His further divides into the left bundle branch and the right bundle branch. The left bundle branch further divides into the left posterior fascicle, which is a thicker fascicle. It helps in the transmission of signals to the posterior and the inferior portions of the left ventricle. And the left anterior fascicle is a narrow portion, narrow band. It helps in the depolarization of the anterior and the superior portions of the left ventricle. Final point is this impulses enters the Purkinje fibers. The Purkinje fibers helps in the transmission of the impulses from the endocardium to the epicardium, which is the final point of the impulse transmission. If you like the video, please subscribe to the channel. Thank you.